want to measure the water level, monitor drainage, detect rainfall, or detect leakage. Solution. If you ever had a water heater explode because not knowing there's no water in the heater, then you know how important it is to detect when water is around. A water level sensor has a series of 10 exposed copper traces, 5 of which are power traces and 5 are sense traces. These traces are interlaced so that there is no sense trace between every 2 power traces. Usually, their traces are connected but bridged by when water submerged. There's a power LED on the board which will light up when the board is powered. The water level sensor is super easy to use and only has 3 pins to connect. So, we'll explain the program. Define sensor power 7, and define sensor pin A, analog 0. It defines constant sensor power and sensor pins. Sensor power is set to pin D7 and sensor pin is set to analog pin. And val equals 0. It declares an integer variable val to store the water level reading. Void setup. Pin mode sensor power output, digital write sensor power low, serial begin. It configures pin D7 as an output and sets it to low to turn off power to the sensor. Serial communication is initiated with a baud rate of 9600. The loop void. It calls the read sensor function to obtain the power level readings, prints the result to the serial monitor, and then introduce a delay of 1 second before the next iteration. The actual implementation of reading the water level from the sensor is not provided in this snippet. You would need to add this part to complete the function. So, the materials that will be used will be the jumper wire, the water level sensor, and the breadboard and the Arduino. This copper wire, this jumper wire will be put on the analog 0. The white one will be on the 5 volt and the other one will be on the ground.